Using the distributive property to simplify rational expressions. Make sure I'm in the right book this time. Good. Alright. So a rational expression is something that is expressed with a variable in the denominator. So that just means that there's going to be a fraction, and in the bottom is going to be some variable. Okay? So we'll just get right into it. We'll review a little bit of our exponent rules along the way. And tomorrow's lesson will be a little bit more on exponent. So, example 1. It says simplify this. Now it has x squared over y squared. And it has open parentheses, x squared again over y plus 3y to the third m, close parentheses. Now, how do we multiply fractions? What's the rule? Go straight across, right? So it's going to apply the same way. So think of this more like as if it were broken down as the top only and the bottom only. Okay, so if I was looking at this, it would be like x squared, and in parentheses I'd have x squared plus 3y to the third. And I would just distribute the x squared. So the x squared to the x squared makes x to the fourth, and then x squared to 3y to the third is just an additional x squared, and I'll put that in order in the next one. And then on the bottom I do the same concept. I have the y squared being distributed to y plus m. When I distribute this out, I get y to the third, and that's plus my squared. Okay, so all I'm doing is this distribution, but I'm doing it all at the same time. So when I distribute this, I get the same concept. I get x to the fourth plus 3x squared y. Okay, so I went ahead and distributed it to both things. And then down here, I distribute it just like I did when I did it down here. And then I get my squared on the bottom. Okay, so now this is my new piece right here. So I need to do anything that I can that would simplify this. So I'm looking here, do I have any matching variables? No. Looking here, do I have any matching variables? Yes, I do. My y's. So which y do I move? I move the top y. Remember, this is y to the 1, so when I move it down here, it becomes subtract 1. And when I subtract it, I get this whole new equation. I'm just going to drop this down right below here so I have room. I didn't do anything with my x to the fourth, y to the third. I couldn't. But I could do something with this. So I moved my y down, but I couldn't move my x down. So I'm going to leave that up top. I didn't do anything with m. And then 2 minus 1 just leaves me y. So this is my final answer right there. So all you're really doing is distributive property and then simplifying after. So distribute, simplify, distribute, simplify. That's basically what we're doing today. Now there is a thing where the bottom, there's a rule that says that you cannot divide anything, I'll put capital A for anything, by 0. It makes it undefined. So make this little side note. Anything divided by 0 is undefined. So when I look at this, I see my original, I see a y on bottom and I see an m on bottom. So I need to go, okay, y and m are on bottom. So if I'm multiplying these, that means that in order to keep these from being undefined, that means that y cannot be equal to 0 and m cannot be equal to 0. Because if they were, then it would make my expression undefined. Now what happens if you have a 0 on top? If I had 0 over a, what is that equal to? Think of it like this, 0 parts of an unknown. Let me put an actual number here, maybe that'll help. 0 parts of 8. So how much do I have? I have 0, right? So don't get these confused. Something over 0 is not 0. It's undefined. There is no answer for it because we can't divide. Because remember how we read these. We have 0 parts of 8. We have some amount of parts, let's say 8 parts of nothing. You can't have 8 parts of nothing. It's like saying I have more nothing than you. There's not a measurement for nothing. So we can't say that. That's what makes it undefined. It doesn't make sense. Okay, moving on. Example 2. It gives us m over z being multiplied by axp over mk. We subtract that from 2m to the fourth p to the fourth. So because I'm multiplying fractions, just for good measure, I'm going to remind myself that I'm multiplying a fraction by putting this whole thing over 1. So that when I distribute my z, I have something to distribute it to. Alright, when I put these in, I want to put them in alphabetical order, okay? So when I distribute out my m, I'm going to rewrite it in alphabetical order. Because multiplication is commutative, I can do that. So m multiplied by axp is a what? A P M L M N O P, so it's M P X. So A M P X. So I just put it in alphabetical order. We're just going to start getting in that habit. If we always put them in alphabetical order, later on when we start combining like terms, we don't get confused by their last name because we put them in alphabetical order. They will all look the same. It's just to help you out later on. So we try to put them in alphabetical order. It's just a standard rule. Okay, and on Z, I'm going to distribute that one out to the bottom. So I have M L K M Z. Sorry. Now I'm going to distribute to the next one. And because this is being subtracted, I still keep my subtraction. Okay, so I'm going to distribute this one out to the next one. I have 2, that's m to the fourth, and this is m, so I have m to the what? Fifth. Good. And then p to the fourth. I'm going to distribute out my z to the bottom one, and I just have z. And again, I'm going to look at these. I'm going to go, okay, is there anything that I can simplify? Is there anything that these two have in common? M, right? And since they're both just m to the first, they'll just end up turning into a big 1. So that one's gone. Can I simplify anything here? No. So I'll just rewrite it with my stuff that I simplified gone. So I have A, P, X over K, Z subtracted from 2m to the fifth, P to the fourth over Z. I guess I should have said subtract from it. And that would be your final answer. I need to identify, these are called excluded values. I need to identify my excluded values from the beginning step, from the very original. So I have a Z, I have an M, and I have a K, and they're all being multiplied. So I have Z is not able to be 0, M is not able to be 0, and K is not able to be 0. Because if they are 0, then it makes our expression here undefined. There's a reason it says rational expression. Okay? It has to be able to make sense. If it doesn't, then it's not rational anymore. Questions? Okay, good. So this is the review of our exponent rules right there. So if we have any questions over our exponent rules, we need to get them handled. They just keep building and keep building and keep building. Alright, on part A, it gives us b to the third over d to the negative 3. Open parenthesis, or multiplied by 2b squared over d minus f to the negative 3 d over b. So there's lots of different ways that I could approach this. I could try to fix everything and put it in positive exponents first, or I can go ahead and distribute, then move. It's whatever you feel more comfortable with. So if I wanted to move this part up here, then I could, and that would make my life a little bit easier. And if I wanted to move that down here, then I could, again, because that would make my life just a little bit easier. But it's up to you on what way you're going to do it. But since most of you will do it as the way you see it, I'm going to go ahead and do it the way we see it. Okay? So we have b to the third, and I'm going to distribute it to the top. So I have b to the third and b to the second, so that makes b to the fifth. Then I'm going to go ahead and do the next one. I have b to the third being multiplied by f to the negative 3 and d. So we have b to the third, d, and f to the negative 3. I just put it in alphabetical order. Then I have d to the negative third being distributed to a positive 1. Now this is the part where it gets tricky. I'm still adding their exponents, but keep in mind negative 3 plus 1 is still a negative 2. Okay? So I have d to the negative 2 now because I'm only adding their exponents. You can distribute it out to the next one, and I have b times d to the negative third. So now I have this, and I need to look at it and say, can I fix anything? Do I need to simplify it? So as a general rule, we do not want a negative exponent. So we need to fix that. How do I fix a negative exponent? I move it. I bring it up to the top. So I'll mark it out here, and I'll bring it to the top. Good. Okay, what about right here? What do I need to do here? I have a b and a b. Which one do I move? From the bottom, right? So it becomes 3 minus 1, since that's just 1. Now, on these two d's, which one do I move? As a general rule, we want to move the one that is smallest. So which one is smaller? Well, this is d to the first. This one's d to the negative. So one furthest left on the number line. So the negative 3 is further left on the number line. So when it goes up top, it becomes plus 3. So it's 1 plus 3. What do I need to do with this f? F to the negative 3, so I need to move it where? Down. So this becomes f to the positive 3 on the bottom. Now I need to rewrite it with all of my adjustments made. So the d went to the top, so I don't have anything on bottom anymore. So it's 2b to the 5th d squared. Squared goes higher. Subtracted from, now I have b to the 3rd minus 1, which is b squared. Then I have d to the 1st plus 3, which is d to the 4th. And then I moved my f to the 3rd to the bottom, so it's f to the 3rd. And this is my answer. I do need to still include my excluded values in what would be excluded. So I want to look for what was there originally. So I had a d in the bottom. I had a b in the bottom. And now I have to look at what I also have in the end. Notice there's an f in the bottom, but there wasn't an f in the bottom at the beginning, but there is now. So I need to look at it and go, okay, so f can also not equal 0, because that would make it not rational. So d does not equal 0, b does not equal 0, and f does not equal 0. You do have to identify the excluded values. This is an easy set of points for you to get, but it's also another easy set of points for you to lose if you don't do them. So it's really easy to identify them, but if you don't write them down, you're going to miss 3 points. Be cognizant of that and diligent. Okay, part B of example 3. It has n to the negative 1 over m. Open parentheses, we have mx over c n to the negative 3 p to the negative 5 plus 5 n to the negative 4 p to the negative 5. So I'm going to show you the other way that I think some of you might like to do this, just for good measure. Some of you might like to fix this before you start doing all of your distribution. So if you want to do that, that is of course okay with me. So I'm just going to move all the things that are negative exponents to the top. Or if they're at the top, I'm going to move them to the bottom. So I'm going to move this into the negative 1 down. It just becomes n. So I'm multiplying now by 1 over mn. And here I have mx still, but I have to move my n to the 3rd to the top. I have to move my p to the 5th to the top. And all I'm left with is c on the bottom. Plus, I have a 5, and I need to move that thing to the bottom. So it becomes n to the 4th on bottom, and I'm going to move that thing to the bottom, which becomes p to the 5th on the bottom. Now I just distribute everything out. So the reason this is somewhat nicer is because when I distribute out this 1, it just stays the same on top. So I don't have to change anything on top. So I distribute my 1 here. I still have mx n to the 3rd p to the 5th plus just 5, because I'm distributing that to the 5 too. On the bottom, I'm distributing my mn, so this becomes cmn, cmn. Down here, I have n and n, which will make n to the 5th. I also have an m that goes into this, so m, and then p to the 5th. Did I confuse anybody with combining that n? Everybody see how that worked? Now I have to ask myself, is there anything that I can combine? So I'm looking here. There's an m and an m. That's nice. That canceled out. There's an n and an n. Which one do I move? Bottom or top? Bottom. So it's 3 minus 1 right there. Okay. Over here, is there anything that I combine? No. So all I need to do is rewrite the front one and put it in alphabetical order since it's not. So I have n to the second, p to the fifth, x. I have c on bottom plus 5 over m n to the fifth, p to the fifth. And I identify my excluded values. So I have a c on bottom, I have an m on bottom, I have an n on bottom, and I have a p on bottom. Then I look back at my original. These are all the same. So I'm going to make sure that all of these are not equal to 0. Hope I didn't miss one. Let me see. C, M, N, P. Good. Questions? It's a lot of letters, guys. Just a lot of letters. I'm going to do example B on example 4 because it deals with a lot of variables and a lot of the same variables at that. So I have g squared h over d squared, open parenthesis, g to the negative 2 xh over d to the negative 1 minus 2 h to the fourth x to the negative 1 plus 9 over d to the negative third. Now again, I have options. If I want to fix stuff before I start combining, I can. If you don't, then just do it the way that we're about to. So I'm distributing a GH to this one. So since there's a G and a G, I'm going to combine those. 2 and negative 2 make what? 2 and negative 2 make what? 0. Anything to the 0 power is what? 1. Right? So basically it becomes 1 multiplied by x times h, which is still x times h. So when I combine my G and my G, it becomes nothing. It goes away, basically. So it becomes nothing. It goes away. But I still have an h, so I have h squared, because h and h make h squared, and I have an x. Now I distribute it to the next one. So this is subtract, and I have 2g squared, and then I have h to the fourth and h, which make h to the fifth, then I have x to the negative 1. Plus, then since that's just 9, I'm going to go ahead and distribute out my g squared h. Setting up my bracket here. I'm going to go ahead and put this over 1. Then distribute out this d squared. So here I have 2 minus 1, which is just 1. So it's just d on the bottom. Since that's just times 1, it's 2 to the power of 2. And then I have a 2 minus a 3, which is a negative 1. So I have d to the negative 1. Now I have to fix all of this. Alright, let's start fixing. Can I fix anything in my first term? Nothing in common. Can I fix anything in my second term? I need to move x down, so I'm going to cross that out, move x down. Anything else? No. What do I need to do here? Need to move d up. Okay, anything else? Okay, so rewrite with my fixes. So I have h squared x over d minus 2g squared h over d squared x plus 9g squared h. Oops, I need to put that d in there. Alphabetical order. d g squared h over nothing. So it's just over 1. But we don't need to write that, so we'll just leave it like it is. And you would be done after you identify excluded values. So I see d and x in my last one. I look at my original. It's just d. So d cannot equal 0 and x cannot equal 0. That's really it. Any questions?